Hello everyone, welcome to the solution of LeetCode problem 136 named single number. In this problem, we are given an integer array. Every element appears twice except for the one element in this array. And we have to find out that element which appears just one times. There is an additional constraint. We have to implement a solution with the linear time complexity, and we have to only use one extra space. Anyways, let's analyze the example 1. In this array, there are 3 elements, which is 2, 2, and 1. But the element 1 appears only one times. So in this case, we have to print 1. In the second example, the array contains 5 elements, and the elements are 4, 1, 2, 1, 2, and here the element 4 appears only one time, so we have to return 4. Now we have to solve it. Before moving to the original solution, let's try to understand the intuition. Here we are given an integer array, and we have to determine for what element the frequency is 1. If one element has the frequency of 1, we have to print it, otherwise we can ignore it. Anyways, this kind of frequency related problem basically can be solved by using hash map or the map in C++. But if we consider map in the solution, we have to take additional extra space, and in the worst case, the size of the map can be equal to the size of the array. So in this case, if the size of the array is n, then the space complexity will also become big O of n. But in this problem, the constraint are we have to use only one extra space. So if we try to solve this problem by using map, the condition is violated. So we have to figure out some other alternative solution in which we can use only one extra space. Anyways, now let's move on to the actual solution. Here we can take a custom example. The input array length is 7, which contains 3, 1, 2, 2, 1, 4, and 4. Here, the element 3 appears only one times, so the answer of this test case is 3. Now, let's try to understand how can we solve this problem by using bit manipulation. In the given input, all of the elements are given pairwise except for the element which is answer. In this example, 4 has 2 times, 1 has 2 times, and 2 also has 2 times. So we can clearly see that in the given input, all of the element appears twice except for the answer element. So if somehow we can eliminate the repetitive elements, then we can come up to a solution. Anyways, the thought process can be seems quite difficult right now, but I will explain it to you. If in this example, at first, we want to eliminate both of the 1, if we can eliminate both of the 1, then our input array will contain 2 2s and 2 4s. In the second operation, if we can eliminate the both of the 2s, then our input array will contain 2 4s and a single 3. And in the third operation, if we somehow eliminate both of the 4, we can end up with a single element in the array, which is the result of this problem. So our problem is now how can we eliminate the duplicate elements. In the bitwise operation, there is an XOR operation in which we can see that in the truth table, if both of the first and second bit become equal, the output of the XOR operation will become 0. Here we can see that if the value of the first operator is 0 and the value of the second operator is 0, the output is 0. And if the value of the first operator is 1 and if the value of the second operator is 1, the output will also be 0. Otherwise, the output will remain 1. We can use exactly this logic to eliminate the duplicate values. Suppose we are in the current element 4 the binary representation of 4 is 100. And suppose we are considering the second 4. So again, the binary representation of this 4 is also 100. And if we perform bitwise XOR operation, the result will become 0, 0, and 0. Because if both of the bits are equal, then the result will be 0 in the bitwise XOR operation. So if we perform bitwise XOR operation between these two 4s, then our output will become 0, 0, and 0. And also if we perform bitwise XOR operation between these two 1s, our output will also become 0, 0, and 0. And if we perform bitwise XOR operation between these two, our output will also become 0, 0, and 0. Finally, we have found 3 zeros, and the only remaining element of this bitwise operation is 3. And if we perform the bitwise XOR operation between 3 and 0, the output will also become 3. Here, the binary representation of 3 is 1 and 1, and the binary representation of 0 is 0 and 0. We are considering only 2 bits here. Now, the bitwise XOR operation between the leftmost bit, which is 1 and 0, is 1, and the bitwise XOR operation in this 1 and 0 will also become 1. So 1, 1 is the binary representation of the value 3. So we can say that if we perform bitwise XOR operation among all of the elements in the input array, the final result will be the answer. Or we can say that the final result appears only one times in the given input. I hope you understand the bitwise explanation of this problem. Now let's move on to the code. This is a pretty straightforward code. At first, we are given a function named single numbers. It has a parameter of the vector, which name is a, and it will return an integer value, the single element. At first, we are taking a constant space variable, which name is result, and we are initializing it by 0. Then we are performing the bitwise XOR operation among all of the array elements. And finally, we are printing the result. Now, let's move on to the time and space complexity of this problem. In this problem, the time complexity is big O of n because while performing the XOR operation, we have to iterate all of the values in the vector. So the time complexity in this algorithm is big O of n in the OR's case. And the space complexity of this algorithm is big O of 1 because we are only taking one extra space to store the XOR value. I hope you understood the time and space complexity. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.